Good afternoon, everybody. Welcome to TechEd Europe. Thanks for having me out here in lovely Amsterdam. I'm very happy to be able to come back. This is optimizing SQL Server performance in a virtual environment. So before I get started, where are my database admins at? Okay, about half the room. Database developers? Okay, a little bit less. Systems admins? People who do everything? People who are thoroughly lost and think this is like an Apple conference? About 8 of you? All right, cool. You guys are going to really enjoy this presentation, I promise. I've got no Mac hardware up here whatsoever. I even left the iPad in my hotel room so Microsoft wouldn't yell at me. So here is my contact information. You'll see my email address in there in the lovely orange box in our beautiful Metro slide deck. So like I said, my name is Denny Cherry. A little bit about me real fast, and then we'll get started to the actual interesting information. I've been working with SQL Server for about 15 years or so now. I am a Microsoft MVP for the SQL Server product. I'm a Microsoft Certified Master for SQL Server 2008. And I am also a VMware V expert. And if you're really, really lucky, you're going to see me fall off the stage today, because I already did that once this week during my pre-con. I am on Twitter on a fairly regular basis, so my Twitter handle is up there as well, as is my URL. If questions do come up after the presentation, feel free to shoot me an email. I'm more than happy to respond to emails, help answer any questions that we don't get answered today. So I've kind of broken today's presentation into 4 topics that we're going to go over. The first one is going to be kind of how to diagnose performance problems when working in a virtual environment, because you do need to look at some extra things when you're dealing with a virtual machine that you wouldn't necessarily need to look at when you're dealing with a physical environment. We're going to talk about the balloon memory driver and memory configuration settings in general and how you want to have those set in a virtual machine to make sure that not only your virtual SQL server's got good performance, but your entire environment has good performance overall. We're going to look at the memory deduplication options that are going to be available in Hyper-V and VMware. And we're going to look at some of the storage configuration options and how you may want to configure your storage in a virtual machine in order to help you get maximum performance out of your virtual machine. One thing to note, unfortunately, I'm not talking about the new Windows Azure VM role in the Azure product that was announced like 2 weeks ago, because I don't have an account yet, so I can't play with it yet and figure out how to make it work better. So hopefully I could do an update to this maybe next year and have some information for you then. So the first thing to look at when working in a virtual machine and trying to diagnose performance problems is to remember that you're not just dealing with the SQL server that we're logging onto anymore. We have other machines that are going to be running as virtual machines in this environment. We have a host platform. I keep bumping into these. We have a host platform that we need to worry about, that we need to see what it's doing as well. And we need to always make sure to correlate the numbers between the host and guest to make sure that we're seeing the numbers that we are actually think we're seeing. Because if we only look at the SQL Server virtual machine, this isn't going to give us the full story of what's going on. A problem that I have seen is I'll log onto a client's virtual machine and look for performance problems, and everything looks fine. I'll look at the CPU on the virtual machine, and the CPU on the virtual machine looks fine, 10, 15, 20%. There should be no performance problems, but the UI is real sluggish, and just the machine is performing like it's got all sorts of CPU problems, even though it doesn't seem to have any. Then as soon as I look at the host platform, all of a sudden I see all sorts of problems. Maybe I see a really high CPU load at the host level. Maybe I see CPU thrashing at the host level. These things that you simply cannot see within a virtual machine because nothing is exposed at the virtual machine level. So you really can't see any of this information through the VM itself. You've got to actually go look at the host platform. So when you're looking at these host platforms, there's a couple of different ways you can look at this information. And how you're going to be able to do this is going to really depend on which host platform you're using. So if you're in a Microsoft Hyper-V environment, you've got two options to see kind of what the CPU is doing. You can log into the host, fire up Task Manager. So if you're in a Hyper-V environment, the host platform is simply a Windows operating system. So you can remote desktop to it just like you would any other server. And you'll either get a full UI or you're going to get a core mode UI, which is just basically a command line window. In either case, you can just run Task Manager, and that'll give you some real high-level information about what the CPUs are doing on that physical machine. And that'll include all the work that all the guests are doing as well that are running on that physical machine. And the second option would be to use Performance Monitor, or perfmon, to go look at that information. So you can do that either on the physical server if it's got a GUI or a graphical user interface installed, or if it doesn't, or if you don't have access to log on to the physical console, but you've got remote access to look at the perfmon data, you can do that through perfmon on your workstation just by loading up Performance Monitor and alerts, I think is what it's called in Windows 7, and just connecting to the remote machine using Windows authentication and pulling down all those metrics. And you can actually be given rights to look at the perfmon data without needing to be given administrative rights to the physical host environment as well. Your system admins can do that simply by dropping you into the Performance Monitor read-only group that's available on every Windows server. And they just drop you in there, and you can actually pull all that perfmon data remotely, from your workstation. And that'll give you an idea kind of what's going on with the CPUs. And you can also look at the disks and the network as well of that host machine and really see if you've got any bottlenecks that are showing up there. So when you're using perfmon, you're going to want to look for CPU problems. You're going to want to look at the physical CPU performance monitors and performance counters that are available in perfmon. Those are going to give you a few different counters to look at, and you want to look for the percent CPU used or the percent used counter in perfmon. That's going to give you how much information or how much CPU load is actually being used on that host, just like you would on any other SQL server that you're looking at if you're looking at perfmon data. Now, if you're in a VMware environment, it's a little bit different on how you get access to this information, because VMware runs on basically a Linux kernel, so you can't exactly remote desktop into the machine and look at this information. So there's a couple of ways you can get access to this information. And unfortunately, I don't have a Hyper-V host, but I do have a VMware host running on my laptop, so we can actually look at this in a second. So your first option is to use the vCenter management tool, which comes with the vCenter, with the VMware host environment, to log on to the host environment and then look at the performance data, which I can show you in just a second here, because I just got my VMware environment back up. And that'll actually give you some overall information as to what's going on with the physical host, so you can see what's going on. So you can see kind of what the performance is at a high level. So this is the VMware performance, or the VMware management tool. It's not the prettiest user interface around, that's for sure. But you get some really good information right here in the middle. This is the host I'm looking at here. And you can see what the CPU and what the memory usage of the host is at a quick glance. If you're in an environment where you've got several hosts in a cluster, they're all going to be listed right here in one pane. So you can see them all right there quickly and easily and get access to all that information at a real high level. And then if need be, you can actually drill into the host and see what all the virtual machines are doing, simply by clicking on the Virtual Machines tab. And that'll let you dive in a little bit deeper at a real quick level and see what all the CPU load is for all your virtual machines when it finally loads. Come on. So Microsoft has something similar to this. It does require purchasing System Center Operations Manager to manage the VMware environment. And we can see right here the memory and CPU usage for these virtual machines running in this environment here. So you can, again, see this through System Center Operations Manager, which you can purchase. It's a Microsoft product that you can use to monitor your entire enterprise, and that will show you all the same information that I'm showing here for a Hyper-V environment, additionally. So the second option you've got available to you to monitor, to see what sort of CPU problems you might be having in your VMware environment, is to actually log on to the physical server's console itself, which I've done here. I've actually SSH'd into the server by turning on the SSH services within VMware. And so you can run an application called ESXtop. Does anybody have a Unix background? show of hands, quarter of the room maybe. So for those of you with a Unix background, you remember the command top that you would run to see what processes were running in your Unix environment. This is very similar to that, obviously. It's called ESX top. So instead of showing individual processes, it actually breaks it down into what the actual virtual machines are and kind of abstracts a little bit of information to make it easier. It shows you some VMware specific information. So you can see here the third item on the list there is SQL 1, which is the virtual machine that I have running within my virtual VMware environment on my laptop. So the important piece of information to look here is both the percent used column of all this output here. These are all the processes running on the machine. If you've got lots of VMs, those will just all be virtual machines because it sorts by the percent used column by default. So your VMs will be all your workload. The other thing to look at is that pCPU used percent at the top there. Do I have a laser pointer? Oh, I do. So this guy right here, percent CPU used percent, or pCPU used percent. And it's right now 1.7, 0.8, 0.3, and 0.7 with an average of 0.9. So each one of those numbers represents a core on the server. So this is a 4-core virtual machine, or 4-core ESX server that's running on my box. So if those numbers get above about 70, 75%, that means we've got a lot of CPU thrashing going on our VMware box, and we're going to see really weird performance problems in our virtual machines, even if those virtual machines don't think they're pushing very much I/O or very much CPU load. So this would be another way to diagnose that in this virtual environment. So the next thing to look at is obviously going to be I/O once you've eliminated or figured out how to look for all your CPU problems. So the reason you need to look for I/O is, again, we're in a shared environment. We've got lots of virtual machines all potentially pushing I/O through the same fiber channel ports. So when you think about your physical either Hyper-V or VMware boxes, you've probably got 2 fiber channel ports coming out of the back or a couple of iSCSI ports coming out of the back that allow you access to your shared storage environment. So if you've got 2 fiber channel ports, those are probably 8 gig ports. If you've got iSCSI ports, hopefully those are 10 gig ports and not 1 gig ports. But that's a limited amount of bandwidth that you've got access to. So these virtual machines are all going to be sharing those cables and the bandwidth available on those cables to get data or get access to the data from the server down to the storage array. So it becomes a very real possibility very, very quickly to actually max those cables out and begin pushing more data through those cables than those cables can actually support. So looking at the disk I/O at the guest level may not tell you this information because, again, you're only seeing part of the story. You need to actually grab both the disk information from the guest and also from the host. And you can use the exact same tools as you can see as they would use for the CPU information to get access to the disk information. You'd use perfmon in the Hyper-V environment or SCOM, System Center Operations Manager, or in the VMware environment, you'd use the vCenter management tool to see the I/O that's being pushed down from the guest down to the storage. And so you want to look at the overall numbers and make sure that what you're seeing isn't really showing you any performance problems. So in the Hyper-V environment, we get a few additional counters because we get all that huge list of counters that Microsoft gives us access to. The important ones to really look at are going to be the percent, or no, sorry, not the percent used, the average seconds per read and the average seconds per write that are going down to the disk. And you want to look at those both at the guest and the host level again, because that's going to tell you how much latency we've got reading that data off the disk. People love looking at the number of reads and writes per second and watching those numbers fluctuate going along. And those are good numbers to look at to see what's going on, but that's certainly not giving you the entire story. You need to actually look at how long it's taking for your commands to actually get down to the storage array. Because we've got lots of machines running on this same disk. So I had a problem a few years ago now when I was over in a managed hosting environment with a company I was working at, where if I had only been looking at the reads and writes per second, I never would have realized what sort of problems I was having. So I was running a SQL server. It was a physical SQL server using shared storage on a storage array. And everything was going fine. All of a sudden, about 1,400 hours in the middle of the afternoon, performance just nosedived. We went from processing tens of thousands of transactions per second to hundreds of transactions per second. So needless to say, something was wrong. So obviously, first thing I did, logged onto the server, brought up perfmon, looked at the amount of I/O going through, very, very low numbers. Okay, that's fine. That doesn't look all that strange. But then I looked at the amount of time it was taking for the I/O to go through, the seconds per read and seconds per write. And those numbers were not in the 5 to 10 millisecond range like they normally were. Those numbers were in the 5 to 10 second range, which is obviously not where they were supposed to be. So I called up the managed service provider and got the first moron on the phone. And he promptly informed me that there was no problem because I was not pushing very much I/O through from the server to the storage array. And I said, yes, I'm well aware of that. That's because I can't get the I/O there fast enough. And he said, no, everything looks fine. You're not pushing very much traffic through. I'm not seeing any problems. So I promptly hung up with him, called back, and got the next guy on the phone. He was a little smarter, and he understood there was a problem and actually escalated me to somebody who could actually figure out my problem. So, like I'd mentioned, we were in a shared environment. We were supposed to be on dedicated disks. And for the most part, we were. The problem was we had bought more storage, and we had extended our LUN. And apparently when they extended the LUN, they did not extend it into our dedicated RAID 5 set. They put the new 100 gigs of storage I had bought in another RAID 5 set, which is fine, except that somebody else was also in that RAID 5 set. And they had a nice, like, 10 terabyte LUN or something carved out of that RAID 5 set. So I get the new storage admin on the phone, or the senior level guy. And he asked me, well, did you buy storage? Yeah, I bought storage a couple months ago. Why? Well, I see that we've got a meta LUN here. We've expanded, so he actually drilled in and went, and the second part of this LUN isn't where it's supposed to be. Okay, well, is it in a shared or dedicated environment? Well, it's shared. There's somebody else's LUN in there. I'm like, okay, is that a file server by any chance? Yeah, I can tell by the server name it's a file server. Okay. Can you ever log on to the other customer server? I'm not supposed to do that. I know, just humor me. So he logs on. I'm like, okay, are they running a defrag on their file server by any chance? Brings up computer management. As a matter of fact, they are. And it's like 10% done. So it's going to be like this for about 4 more days. Awesome. So I'll call my boss and let him know that you're going to move us to a new RAID set, or to a new RAID group. He's like, yep, I'll get that started right now. Give me about 10 minutes. And so he got that process started, and I'm like, and that's going to take 12, 14 hours? He's like, yeah, that sounds about right. I'm like, all right, I'll let my boss know. He'll call our account manager, yell at them, and get us a refund for the day. He said, all right, sounds good. I'll put in my notes that we owe you some money. But if we hadn't looked at the right counters, and we hadn't looked at the aggregate counters on the storage array to see what was going on for the entire system, we never would have been able to figure out what the actual problem was, because we wouldn't have had all the information just by looking at the perfmon counters on our host. So that's why we always want to look at both the guest and the host level to really see what's going on, because we've got to get that whole story. Now, I have good news and bad news. The good news is you can get access to SCOM and the vCenter management tool. The bad news is you have to talk to your systems administrators to get access to that. And that may or may not be the easiest conversation in the world to have. Now, there is a little bit more good news. When they do go to give you these rights, if they say they don't want to, they can give you read-only rights into these environments. So you don't have to be able to create virtual machines to be able to see this stuff. A little bit more good news, all this information in both vCenter and System Center Operation Manager is stored in a product that hopefully everyone in this room is familiar with called Microsoft SQL Server. So you can just log into the SQL Server directly and simply query this information out of those schemas if absolutely necessary. And then you can throw it into Excel or something and look at the data that way. Both the schemas for SCOM and vCenter are published on the internet, so very well documented. So you can just download those reference documents to figure out how to write the queries to actually pull the data out of these systems. That or shoot me an email. I can send you some sample queries that I've got to help move the process along a little bit. So within both VMware and Hyper-V, we have a process called the balloon memory driver. Anybody ever heard of this before? A few? Okay. Those of you who have heard of it, anybody scared of the balloon memory driver? A few? Okay. Well, let's dispel some of those fears real fast. So what the balloon memory driver does, for those of you who haven't heard of it, is it basically takes memory back from the guest operating system and returns it to the host for a short period of time. So the reason it does this is because the host operating system needs memory. The reason it needs memory is because probably something bad is happening. Now, the balloon memory driver has gotten a very bad rap over the last few years, and it's been blamed on a lot of things that it probably shouldn't be blamed on. A lot of people think that the balloon memory driver is simply going to steal memory away from the guest operating system whenever it pleases and return it to the host operating system. That is not the case. The balloon memory driver only takes memory from guests when the host is out of memory. So if your host environment still has plenty of memory left available to it, your balloon memory driver is not going to be taking memory from your guest and returning it to the host operating system. So the big reason we want the balloon memory driver is because it's going to prevent the host operating system from paging our guests back down to the disk. So how the balloon memory driver works is it's simply a Windows process that runs within your virtual machine. And when the host operating system says, hey, I need more memory, I'm out of memory, and it needs to be able to do something, that doing something could be that it's going to start up another virtual machine. Maybe the backup process is running at the host and it needs a little bit more memory. Usually something fairly bad has happened in the physical world that's causing this to happen. A host has failed, and all of a sudden we're trying to start a bunch of VMs all at once. And maybe we don't quite have enough memory to do that because maybe we're a little oversubscribed in our environment. So the balloon memory driver will then kick in and borrow a little bit of memory from all our virtual machines. So the way it does this is the host contacts the balloon memory driver on the guest and says, I need to get back some memory. The balloon memory driver then simply, it's again, just a process running in Windows. It just simply goes and starts allocating memory the exact same way every other Windows process does. I've seen things on forums, and I've heard people say that it will, simply use some high-level API commands. It'll just grab whatever memory it wants, and whatever process is using that memory is just going to fail. That is not the case. What it does is it uses the normal memory allocation processes in Windows. So it's simply going to allocate memory and start growing its memory footprint. And you'll see this in perfmon or in Task Manager in your guest operating system. You'll see this random application start growing its memory, much like a balloon would grow as it's being inflated. What it then does is it figures out which blocks of memory it has, and it reports those blocks back to the host operating system and says, hey, these blocks are free. You can now use them for whatever you need to do. The host does whatever it needs to do. It resolves whatever problem it needs to resolve. And then it simply releases that memory back to the balloon memory driver. So when the balloon memory driver is growing its memory footprint inside the guest operating system, and again, this works on either Hyper-V or VMware this way, as it's growing its footprint, all it's doing again is telling Windows, hey, give me memory. I need memory. Windows is simply going to go to whatever process has the most memory. In this case, that's going to be SQL Server, and go, hey, give me memory. I need some memory back. SQL Server will then respond by simply giving it memory. SQL OS will accept these calls, and it'll remove data from the buffer pool and from the procedure cache and reduce its memory footprint, return that memory back to the OS. The OS then hands that memory off to the balloon memory driver. Nothing bad is happening at this point. Something bad is happening at the host level, but all that's happening inside your VM is a little bit of memory has been taken away. You've got a 64 gig VM maybe, so it takes a couple of gigs away. You've got a little bit of a performance hit, probably not so much you're going to actually notice it. And again, you're going to get that memory back once everything comes back. So you can disable the balloon memory driver if you so desire. Personally, I recommend not doing that. And the reason I recommend not doing that is because if you've disabled the balloon memory driver on all your guests and your host runs out of memory and needs to reclaim memory and can't, it has another option available to it. That other option is paging. So within SQL Server, when running in the guest operating system, SQL Server knows not to page its memory out unless something really, really strange happens. There's a few bugs that have creeped up over the years in Windows or in HBA drivers and whatnot that have forced SQL Server to dump all its memory. That's why a lot of us may have lock pages in memory turned on. But under normal circumstances, SQL Server will not page to the Windows page file. But now at the host level, it doesn't know about SQL Server. It's not going to tell SQL Server to page out. It's simply going to take whatever memory it desires from the physical memory and page it down to the disk so the host operating system can get back whatever memory it wants. Now, within SQL Server, all we're going to see at that point is bad performance, and we're never going to be able to figure out why, because we're not going to realize that we've been paged out unless we actually go look at that host environment and see that we've been paged and see how much paging is happening. So if you've got the balloon memory driver on, you may use a little bit of memory every now and then when something's going on in the physical world. But if you've got it disabled, when that thing goes wrong in the physical world, you run a serious risk of getting paged to disk and not being able to tell. And in my mind, that's a lot worse than losing a few gigs of buffer pool on a random basis or an occasional basis. Now, I've got lock pages in memory up here because in my personal opinion, lock pages in memory should be disabled unless you've got a very specific reason to enable it. And I say this for both physical and virtual machines. I like to see it disabled because I want to know what bugs creep up that causes SQL Server to page to disk or to be pushed down to the page file. Under normal circumstances, lock pages in memory should be doing absolutely nothing for you. The only thing that setting does is tell SQL Server that when told to page to disk, ignore it. So if you've got a server that's never telling SQL Server to page to disk, having that setting turned on is never going to do you any problem, never going to give you any benefit. But now if I've got it turned off, and I do receive one of those commands that tells me to page to disk, I can now see that something is wrong, turn the setting on, call PSS, report the problem, get them the dump file, and then I can go on with my day, leaving lock pages of memory turned on until I get a hot fix from Microsoft PSS, or CSS, or whatever they're called today, to then fix whatever problem that is and move on. And then I can turn it off and wait for the next bug to come up. Now, knock on wood, I haven't seen any bugs come up in quite a while that cause SQL servers to page out or to be paged to disk. The last real bad ones I heard of is there was a couple of HBA driver bugs about 7 years ago that would cause it to page out. And there was a real nasty bug in Windows 2003 RTM that when you remote desktop to the server would cause every process to page to disk. This was obviously bad if you had like a 64 gig box or a 32 gig box running under Windows 2003 because it takes a while to write all that memory down to the disk. But those bugs have obviously long been squashed by now. And there, as far as I know, there's nothing else that's going to really cause you to page out. But you really want to know what's going on and if there is a bug. Because if there's a bug that's causing you to page to disk, who knows what else that bug is causing that you're simply not seeing because lock pages in memory is turned off. So to get around some of these potential problems with memory ballooning, I'll talk about memory reservations for a second. So memory reservations are an additional setting on the virtual machine that specify basically a minimum amount of RAM that's always going to be available to the virtual machine. So when we build a virtual machine, we tell it maybe I want 64 gigs of RAM for the VM. So we create the VM, give it 64 gigs of RAM, everything's happy. By default, the memory reservation is 0. So what I may want to do is if I'm worried about ballooning and taking memory away, I'll set the memory reservation for these servers to some setting. And that setting is going to be whatever the minimum amount of memory is that I need to keep my application functional. Not running at peak performance, but make sure it's running. Because we want to be able to return some of that memory in these weird emergency situations back to our host platform. So if I've got a 64 gig box and I know that I need 32 gigs of memory for SQL Server to make sure that the virtual machine is running like I want it to be running, maybe I'll set, so I'll set the memory reservation to say 36 or 38 gigs. That'll give the virtual machine enough memory for SQL Server to do what it needs to do, and it'll give the Windows operating system enough memory to be able to do what it needs to do to be able to function under this emergency situation where it's got this limited amount of memory. Because again, we're not trying to keep the system running at peak performance. We're trying to keep the system running at good enough performance to keep everything functional and moving along quite quickly. So the other thing you're going to want to do is make sure you've got hot memory add enabled for your virtual machines. So this is a setting that's available in VMware and Hyper-V. Again, sorry, unfortunately I don't have Hyper-V configured, so I can't show it, but I can show it in the VMware at least. So if you edit the settings for the virtual machine, you have to have the virtual machine off to change the settings, so you have to take a quick outage. So just power down the virtual machine, and what you want to do is change that top setting. You go to Properties. I'll show you where it is in the UI. Oops. Edit settings. So you go to the Options and Memory CPU Hot Plug, and you want to turn on Enable Memory Hot Add for this virtual machine. Now, this does require that your guest operating system is running Enterprise Edition. So this, if you're running Standard Edition of Windows, this won't work for you, but it will work for Enterprise Edition of Windows. You can simply enable, if you turn this setting on and then power the virtual machine back up, if you need to add more memory to this virtual machine, you can do it without taking the virtual machine offline. You simply change the setting in the UI for the amount of memory you want to give it, click OK. It changes the amount of memory that the guest has. You go into SQL Server, reconfigure SQL Server to increase the amount of memory through max server memory, and suddenly SQL Server's got access to more memory. This gives you a nice way to be able to upgrade your virtual machines without taking an outage to do the upgrade, because it does this online without any reconfiguration necessary of the virtual machine. So within the Hyper-V and VMware platforms, we've got an option called memory deduplication. So what this does is allows us to oversubscribe our memory and get a little bit extra memory on our host platform. So this works really well for the operating system memory that we have within our guest operating systems. For the most part, it's not going to work so well for your buffer pool or your procedure cache, because we're going to have different buffer pool and procedure cache across the entire virtual machine environment, or across all our virtual machines. But even doing this just for the OSs can give you a decent amount of memory savings when getting everything configured and up and running. So the way this works is, and again, this works basically the same in both platforms, is we have all our memory sitting up in physical RAM. We've got, say, 20 virtual machines, all with the same 4 or 6 gigs of memory allocated running Windows. So if we've got everything up there running happily, we're going to have a lot of duplicate memory. So what the host platform does is it looks at the memory that's in, the data that's in memory, and it grabs hashes of all of it. If it sees that the same 4K page is in memory, it'll simply take those 2 pages, it'll discard one of them and put a pointer into the first one, simply saying, all right, put the memory here, or use this memory over here and grab it, and we're done. We don't need to really do anything else at that point. And all the virtual machines then can continue looking at what they think is their own memory, but they're actually all looking at the same page of memory. So this gives us a nice boost in the physical memory available, so we can do things like spin up extra virtual machines or oversubscribe the memory on our host a little bit, because we've got all this extra memory suddenly available. Because if you think about the fact we've got, say, 20 machines, 4 gigs of memory each, that should be 80 gigs of physical memory all being eaten up by these virtual machines. But if we can get that 80 gigs down to like 6 or 8 gigs, that's a lot of memory that we can oversubscribe and use for something else. So that gives us a decent amount of oversubscription and a decent amount of potential performance savings in the event that there is a problem, because we might not need now to use the balloon memory driver to steal memory back, because we've got all this extra memory sitting up that we can use in the physical world. Now, if your SQL servers do happen to have the same data in cache for some reason, maybe we've got dev, QA, and staging systems all with the exact same data set, then that would this memory deduplication option would work with those SQL Server data pages because the pages would all be the same at that point, assuming all your database IDs and stuff are exactly the same. So storage is usually the place where we end up with the most performance problems and the most configuration problems in virtual machines. And that's because we end up putting all our virtual machine data files just on one LUN and it just goes. We've kind of gotten back a little bit to the storage array is just a big black box. Let's just throw all the data on one LUN and it'll be fine. And obviously that does not necessarily work for high I/O SQL Server environments. So our I/O requirements when looking at moving a machine from the physical world to the virtual world are going to be basically the same. We're not, even though we're abstracting a lot of hardware, we still can't abstract the I/O that we need to get down to the disk. And we still can solve I/O problems in much the same ways as we would in the physical environment. Add more memory. If our problem is that we're reading too much data from the disk, that'll get more data into the buffer pool and reduce the number of read I/Os that we're doing. Or split the data across multiple LUNs so we can get more physical disk resources behind it. So I get asked fairly frequently is when I'm building virtual machines, do I want to put my data on an OS drive, a data drive, a log drive, and a tempdb drive, even if those are all going to be on the same physical LUN or the same storage group or storage pool within the host environment? And my answer to that is yes, for a couple of reasons. The first one, each disk that the guest operating system sees, that the Windows OS sees, is going to have its own disk queue. So if we do have some sort of I/O performance problem with commands queuing up on, say, a transaction log drive, for some reason, we're not able to push writes through for some reason, and we've got everything on separate volumes, that transaction log drive is going to get that queuing, but maybe when that's happening, we can still do reads because the head is in the right position to do the read request that we want to do. So if the data file is sitting on a separate volume, we may still get the read back even though the write has been queued. So that's one reason to separate things out. The second reason I want to separate things out is a little more plain and simple. When we do want to break things apart later, they're already broken apart. We've already got a physical VMDK or virtual disk file for our data. We've got a second one for our logs, another one for tempdb. So when we do get to the point where we go, okay, well, we do need to move the transaction log to another physical LUN from the data file drive, we don't need to take any sort of outage to do that. We don't need to present a new virtual disk and then down SQL Server and move transaction log files around because everything's already on its own virtual disk, and we can simply move that file in the physical world from one LUN to another without really taking any sort of outage. Now, if you're in Hyper-V 2, there's currently no way to move that virtual disk live from one LUN to another. You've got to wait for Hyper-V version 3 to come out with Windows Server 2012. So once that comes out, then you'll be able to do that migration live. If you're in the VMware world, better news, you can move those disks live without any sort of performance impact. I believe it requires Enterprise Edition of VMware to make that happen. But if you're running in a big cluster in a large shop, you've probably got the VMware Enterprise Edition if you're in a VMware shop. It's literally just simply a matter of right-clicking on the VM, going to migrate, telling it I want to move the storage, click next, and tell it where you want to put the storage. And I can actually show that to you because I have VMware up and running. At least I can get most of the way through it. Helps if I switch to the right computer. So all I've done here is I've simply right-clicked on the VM, gone to migrate. I only have one host, so the first option is disabled. Just select Change Data Store, click Next, which you can't see. Select the new data store you want to move the disk to. Click Next, click Finish, and it moves it. No outage required. No real impact to the end users. You might see a little bit of a slowdown of performance while it's moving that data, but that's it. You're not going to really see any real problems, and you shouldn't see that much of a performance problem because it's doing everything in the background. The guest never knows that the data has been moved from one LUN to another, so it's nice and easy to do. So if you're in an environment that's got automatic storage tiering, I would highly recommend using it. So a lot of the storage array vendors have this auto tiering technology They all call it different things, but the basic concept is I create a pool of disks, some flash or SSD, some fiber channel, and a lot of SATA. And I simply create my LUNs in this pool of storage instead of on a specific RAID 5 set or a specific RAID 10 set. And whatever data I'm using the most, that data gets moved to the flash drives automatically, and the slower data or the less used data gets moved down to the slower storage. Now, I recommend using the auto tiering only for your data files and probably your operating systems, or possibly your operating systems, depending on if you need it there or not. The reason I don't recommend this typically for transaction logs is because by the time the storage array detects a hotspot in your transaction log, because you've been writing a bunch of data, and it moves it into the flash space, you're already not using that space anymore. Because don't forget, our transaction logs are circular, and we just go down through the entire file, top to bottom. So by the time we get, by the time we've gotten through writing to a section of disk and it moves it to flash, we're not writing to that section of disk anymore. Also, flash drives are usually not so great for transaction logs unless you have a way to turn that sequential write activity into random I/O, because flash drives don't typically like working with sequential I/O very much. So your TempDB will usually do fine on that auto-tiering environment, as will obviously your database files, but your transaction logs usually won't. So there's a couple of different ways you can present storage to your virtual machine, and using some of these techniques, you can usually get a little bit better performance if you are hitting bottlenecks and want to get a little bit more performance out of your storage environment. So the default way to present storage to a virtual machine is to create a virtual disk or a VMDK. And that's simply a file on the host operating system's LUN that's presented to the guest OS as a hard drive. This will work fine for most environments, especially anything with low I/O requirements. This will work just fine. Once you get above those low I/O requirements, though, that's when you're going to want to look at one of the other two options that's going to be available to you. The first one is to simply use iSCSI and connect your guest operating system directly to an iSCSI storage array. So if you've got something like an EMC or a NetApp or a Hitachi or something like that that's got iSCSI ports actually on it and can present storage directly over iSCSI itself, this may be an option for you. So what you do is you go into your guest operating system and simply configure the iSCSI initiator to go talk to the iSCSI storage array on the storage array. Once you've done that, you can then, as far as the storage array is concerned, the guest operating system is just another server trying to request storage. So you can carve up storage, present the LUN directly to the guest OS, and get access to the storage directly. Then move your databases from what was the VMDK now to the iSCSI storage array. Now, iSCSI does have a couple of limitations that you need to remember. It is using TCP/IP to transmit its data, so you do need to do things like enable jumbo frames to maximize the amount of throughput across your Ethernet environment, and you'll want at least 1 gig network, several 1 gig network cards, preferably some 10 gig network cards, to get the amount of data being able to push through as much as possible. Also, obviously, you want to make sure you've got redundancy at the physical environment to maximize the amount of bandwidth you've got and to ensure that you don't lose access to that storage if a network switch is rebooted or something like that. So the other option you've got available to you, which I prefer, especially if you're in a fiber channel environment, is either a raw device mapping if you're in the VMware world or a pass-through disk if you're in the Hyper-V world. So what these disks are going to do is you're basically going to create a LUN on the storage array, or your storage admin is going to create a LUN on the storage array. It's going to present that LUN to the physical environment, the physical host environment, and then you're going to go into your virtual machine configuration, and you're actually going to manually add that LUN as a device on the guest operating system. This effectively gives the guest operating system access to the storage array through the fiber channel without needing to go through the translation process of using a VMDK. So this can get you a couple extra % of performance out of your guest operating system's I/O requirement, or out of your guest operating system's I/O. So that may help alleviate a little bit of problem, may alleviate a little contention, take a little CPU load off the host system as well, all in the same process. So to do that, again, you just edit the settings of the virtual machine. And this is very similar in Hyper-V as well. You add a new hard drive. I can only get about halfway through this wizard because I don't have a raw device I can use. And you select this bottom option down here that says raw device mappings that I've got grayed out. Unfortunately, I don't have a storage array, so I can't present a raw device to the guest. But you just select the raw device mapping, click Next. It's going to ask you what SCSI ID you want it assigned to. Select one, click Next, click Finish. And then that LUN will then be presented to the guest operating system, and the guest operating system will then be what formats it and controls that LUN. So you won't see any difference between a physical server having a LUN and a virtual machine having either a raw device mapping or a pass-through disk, excuse me. I think I'm finally getting converted from California time to Central European time. Yeah, question. Oh, thank you very much. So Hyper-V version 3 coming in Windows Server 2012 will support having virtual fiber channel adapters or virtual HBAs within the guest operating system. So that'll be another option available to you within once you are able to upgrade to Hyper-V version 3 under Windows Server 2012 at the host level. So they'll give you another option for presenting storage to the guest operating system. VMware used to have that as an option, but it didn't work very well. It was experimental, so I think they ended up pulling it out, and it's not available there either. So another technique that can actually help improve your I/O performance is called storage deduplication. So what storage deduplication does is it basically compresses and deduplicates data as it's written to the storage array. So this can be extremely helpful for Hyper-V systems, or not Hyper-V systems, for OS LUNs or OS virtual disks, because the OS has a lot of duplicate data. And if we can solve a lot of performance problems by loading our OSs off the storage array, we can then free up that I/O for other things, like, say, our SQL Server databases, so they can get more I/O that way. So the way this works is a lot like the memory deduplication at the host level, but we're actually deduplicating the data as it's written to the storage array itself. So this is an option on some storage arrays. You'll need to check with your storage array vendor to see if they support it. Maybe you just need a software upgrade to get the support enabled. And you can actually deduplicate a decent amount of data as it's being written to the storage array. I turned this on an encrypted medical billing database out in the US and was actually surprised that I actually was able to deduplicate a decent amount of data. I think I was able to deduplicate something like 20% of the data, removing it from the storage array so I didn't have to store it anymore. So the way this really helps us out is because once we've deduplicated this data, when our virtual machines are requesting the data, they're going to go say, hey, I need this data. The host passes that request to the storage array. The storage array looks in its cache for data. If that data is not available in cache, it's got to go to the disk and get it, and then load that data into the cache. Well, if I've got requests all going to looking for what I think are different pieces of data, but they're actually all the same, excuse me, and when that request gets to the storage array, once that data is loaded in the cache of the storage array, any other requests for that data, for what I think is different data, are all coming off the same physical block. So they're just going to come out of the cache at that point. So performance is going to be much, much better because I'm not reading and writing. I'm not reading the same block of data over and over and over again. This becomes extremely important and extremely handy in the event that I lose a physical server, because now I've got a big problem. I've got to boot 10, 15, 20 virtual machines basically all at the same time. So the first virtual machine is going to boot. That's going to read the operating system from disk and put it in the cache of the storage array. And now once all the other virtual machines go to boot, they're just going to read those pages out of cache because they're the same physical blocks that are sitting on disk. So I can get much faster boot times out of them. And I'm now not putting all that extra stress on my storage array because I'm not reading all these other blocks that are basically, that are actually just redundant data at that point. So it gives us a better performance at boot, but also overall as the system keeps running. So If you didn't catch it at the beginning of this presentation, I mentioned monitoring a little bit for like 10 minutes. So monitoring in these environments is extremely important because you need to really keep an eye on what's going on and keep track of how things are working. Because if you're not correlating this information back from the physical layer to the virtual layer, you're not going to get a good idea of how things are actually running and what's really going on. So I've got listed here 5 different places that you need to monitor within your storage or within your environment to make sure that you've got good monitoring and that you're seeing all the pieces of information that you need. So obviously you need to be monitoring your SQL server, or hopefully that's obvious to everybody here in the room. But you also need to be monitoring the guest operating system and getting information out of there. You need to be monitoring your hypervisor, your host, and your storage environment. At all those different places, you need to be looking at all the various numbers that are available to you and correlating those numbers back and forth to make sure you're seeing what you really think you're seeing. Because if you're not doing that correlation, like I had mentioned at the beginning of the deck, you're not really going to see if there's a performance problem at the host level, but that's not showing up at the guest level. So the guest, the hypervisor, and the host, those are fairly easy to monitor. You can do that through perfmon or through the VMware monitoring tool. So if you're in a Hyper-V environment, you can monitor this stuff long-term using System Center Operation Manager or any other monitoring tool that can grab data from perfmon. If you're in a vCenter environment, the host and hypervisor information is all going to be captured for you by the vCenter management tool, and that's going to be able to allow you to trend it over long periods of time to get access to the information that you need. Both SCOM, or System Center Operation Manager, and vCenter are going to keep data for, I believe, 12 to 13 months by default. So you can do some real long-term trending analysis on what's going on and make sure that everything's going like you think it is. So you're going to want to make sure that all your systems are keeping that data for long periods of time. The storage world, it's a little harder to monitor long-term for performance problems. The reason for this is there's no real way in most systems or most storage arrays to get the data out of the storage array to some other system. Some storage arrays include a monitoring component for free. Some don't, and they charge a little extra for it. If your storage vendor does charge extra for the monitoring product and you have not purchased it, you should go purchase it. They will save you tons of time, and that time translates to money because when you're going to be looking at them, you're going to be in a system down situation. I've had clients complain that I forced them to purchase the monitoring product for their storage arrays until they have problems, because then they can actually see where those problems are and actually get those problems resolved fairly quickly because they can actually see the information and see what's going on within the storage array. And apparently they did not put the new slides in here that I asked them to. So if you're working in a Hyper-V environment, there's an additional storage driver. Sorry, if you're in a VMware environment, not a Hyper-V environment, there's an additional storage driver that's available to you called the Paravirtualization driver. What this driver does is it bundles up the writes that are going down to your storage array and gives you better performance in high I/O environments. So the way you enable this virtualization driver is first you stop the virtual machine. And you never want to stop the virtual machine the way I just did, because I just crashed Windows. But there's no Windows operating system on this virtual machine. All it is a dummy OS, because I'm running this within ESX, within VMware Workstation, inside Windows 7. So I've got this like chain of things, and I really didn't want to try running Windows underneath all of that mess. So what you do is you edit the virtual machine, click on the SCSI controller. So if you've got a bunch of disks, you may end up having multiple SCSI controllers. If that's the case, you're going to want to look at each individual hard drive to see which one they're connected to. And how you see which one they're connected to is the first number of that hard drive name, which says SCSI open bracket 0:. That first 0 tells me which SCSI controller this hard drive is connected to. So in this case, this is connected to SCSI controller 0, obviously. So we click on the SCSI controller, and we go to Change Type. And oops, there we go. So we can see 4 options listed here. the bus logic parallel driver, which we don't want to use because it says not recommended, the LSI parallel driver, and the LSI logic SAS driver. So that's the default that's selected there. So if I was in a high I/O environment, a high write I/O environment, I'd want to select the VMware Paravirtualization driver. Click OK and restart the virtual machine. If you're adding new virtual disks and those virtual disks are being added to a new SCSI controller, you can do this online while the box is up and running. But if you're doing it on an existing SCSI driver, you're going to need to shut down the guest to make this change. Once you make this change and restart the operating system, you'll then get the new driver installed. Windows install new hardware components. Probably need to reboot one more time. But then you'll actually see higher throughput going down to the physical hard drive once you start pushing writes down to the disk again. Now, this does throw a little monkey wrench into your perfmon counters. When you look at the write I/O perfmon counters, the traditional ones that we've always been looking at, and the number of writes per second, and then the response time for writes, those numbers are now going to be wrong. What those numbers are going to show is what the paravirtualization driver is actually sending down to the disk. So if you normally see 10,000 I/O per second going down to the disk, and you turn on the paravirtualization driver, that number may now drop to like 16. And the reason for that is that that perfmon counter is now showing you what the virtualization driver is pushing down. If you look in the perfmon counters, you'll actually see at the bottom a new perfmon counter called VM disk. That VM disk perfmon counter is going to then show you what the actual performance metrics are going to be as you're pushing, as all the data is being written. That's going to show you what you're used to seeing, basically. There's also going to be a VM memory perfmon counter that you may see in there as well, depending if you've got what memory settings you've got enabled in the VMware environment. And that'll show you some additional information as well that may be useful in doing some performance tuning. So look for both of those perfmon counter groups in Performance Monitor on your guest operating system if you're in a VMware environment. So let me find the slide deck real fast that I sent in that they didn't forgot to put on the console here. So here's some of the performance monitor counters you're going to want to monitor over time. So I think I talked about most of these already. Reads and writes per second, seconds per read and write, the disk queue counters. SQL Server is going to try and build up the disk queue as high as it can, but you do still want to keep an eye on these counters to really make sure that you've got, a good idea of what your baseline is. One thing always to remember when dealing with performance monitoring and performance troubleshooting is if you don't have a baseline of what things are supposed to be normally, you have no idea if things are actually bad. So monitor all these regularly to see what is going on currently when things are working normally or when you think things are working normally. And make sure you update that baseline over time. Hopefully all your companies are growing as our economy slowly starts to recover. Well, at least our economy in the States starts to recover. I don't know how bad things got here. Hopefully not as bad as they were over in the States. But as things recover, hopefully our businesses are all growing. So we need to update our baselines, every 6 to 12 months, because as our businesses grow, we're putting hopefully more load on our SQL servers. So we need to have a more updated version of normal, of what things are supposed to look like. Page life expectancy, definitely something I hope everybody is monitoring on a very regular basis, because if you're not monitoring that, you have no idea how healthy your SQL servers are. That is one of my favorite perfmon counters to look at when I go walking into a new client, because by looking at that, I can get a fairly good idea of how bad things are in their SQL Server environment. If their page life expectancy is 14 seconds, I know there's a problem. I also know how to fix it, spend money. I like spending other people's money, so I tell them to go buy more RAM. We install the RAM, problems are solved. Hey, look, all your performance problems went away. I actually have a client where PLE is 12 seconds, and that's normal at this point for them because they're SQL Server 2000 standard edition. So they're limited to 2 gigs of RAM. It's brutal. They're also one of the biggest office furniture manufacturers in the States. So they have a huge data flow going through that system. Another counter I want to look at is the system processor queue. And if you're going to work on a physical to virtual migration project, definitely look at this counter on the physical boxes and compare it to your virtual machine, and compare it to what you get in your virtual machine after you do your migration. This is a system-wide counter. It's not per core or per CPU in your server. And you want this number as close to 0 as you can get. If this number is starting to get higher and higher and higher, you're going to start having all sorts of performance problems because your commands going to the processor are having to wait. And if you've got commands waiting for a processor, you need a hardware upgrade. That's basically your only option unless you've got some real bad indexing, lack of indexing or something like that going on. The easiest way to fix this problem, add more CPU. So if you're in a virtual machine environment and you're seeing this number going up, and by up I mean like anything over 2 I consider bad. Microsoft's got some official fancy formula based on the number of cores and workload and like how many chickens you have within 50 miles of your house and all sorts of funny metrics. I ignore though, and I say if it's 1, that's starting to get bad. If it's 2 or higher, I want more CPUs because I need to distribute more workload out. This is just basically telling you you've got parallelism problems possibly. The VM disk and the VM memory counters that I mentioned, if you're in a, this clicker is not going to help me any. If you're in a VMware environment, there's a lip right here that's like ½ an inch. Very scary when you walk backwards onto it. You want to grab those 2 counters and make sure you're trending those over time as well. That is the old related content. So I think that was the only other slide. So I already talked about that slide. All right, so let me go ahead and open it up to questions if anybody's got any. So some related content for you. So here is, if you anybody in here certified? Microsoft certified? A few of you? All right, cool. So those of you that aren't, I would recommend looking into it for the SQL Server 2012 platform. The tests are very hard, sorry to say. I'm also proud to say they're very hard, which means that when you pass them, that means a lot more than it did in the SQL 2000 days, because it means that you've seriously earned something. So Microsoft's trying to get away from the whole paper MCSE problem they had 10, 15 years ago. So the certifications are very robust and do definitely stand on their own. I'm proud to say that I helped work on some of the 2012 exams, so if you failed, I'm sorry, but that was on purpose. So don't forget, we've got the SQL Server Twitter account and the TechEd Europe Twitter account here in the European conference. So you can follow those for updates about SQL Server and about both this year's TechEd and next year's. I don't know why this slide's so pretty, it's animated. There's some links for you. Basically, it's all the various Microsoft links that are available to you. Don't forget to do your evals, which should be the next slide. Yes, I remembered correctly. At europe.msteched.com/sessions. Hopefully you're submitting evals for all the sessions you see here at the conference today. This is how 2 things happen. First, we as speakers get better because we know what we did wrong and, more importantly, hopefully what we did right. So we want to know not only the scoring, but comments. Leave comments for the speakers. That's the part that's gold to us, so that we know what we did better and what we did right and what we did wrong. So please go ahead and do fill out those surveys, preferably all 5s. That's what we like to see, because those evals are how TechEd decides if we're going to come back next year. So hopefully you all liked me and you liked the presentation here today. So if you've got questions, raise a hand. Seriously? 1? Okay, cool. Yes, sir. So why is it there? So the gentleman's question is, in 2008 R2 64-bit, we've still got the AWE option available. So why? It actually does nothing in the 64-bit platform, since it is the 32-bit option. So it's just there for consistency across the 32-bit and 64-bit platforms. You'll notice that is gone in SQL Server 2012. So they have actually removed that option. I believe it is still listed in the SP configure, but it doesn't do anything at this point. All the code behind that option has been removed from the product. So if you are using 32-bit, you're limited to 2 gigs of RAM or 4 gigs of RAM at this point because AWE is gone. Yes? So he's asking about NUMA configurations and hard NUMA versus soft NUMA configurations in virtual machines, and do you want to try to align things in the guest environments and the host environments and whatnot? And yeah, you definitely do want to try to keep things aligned. It does get a little harder in the virtual environment because you don't really know what's going on. The virtual machines or the virtual hosts do pass the NUMA configuration down to the guest, so the guest will still see what NUMA nodes it's on. And you'll see this when SQL Server is starting, especially in SQL Server 2012, because you'll see the NUMA configuration in the error log file. And yeah, you definitely do want to try and keep the memory and the CPUs all aligned correctly, just like you would in the physical world, so that you can decrease the amount of time that SQL Server takes to access the physical memory. Any other questions? No? Well, I thank you all very much for coming. Go ahead and let you get out of here a couple minutes early, hopefully get you down to the lunchroom before anybody else, because I know those lines get painfully long very quickly. Thank you all very much for coming to TechEd. Thanks for coming to my session. Enjoy the rest of your week.